Okay guys, so today we are going to talk about Dockers. So how Dockers help us, and then what is the difference between Docker and VM machine. So few concepts we are going to understand, then Docker file, then Docker compose, what is Docker hub and all that. So let's start. We'll skip few theoretical things, right, because we don't want to invest our time in that. We actually want to understand why we need to use Docker. Then when we say Docker platform, so what does it contain? Docker installation we have already performed, and then we will understand the workflow of the Docker, like how to create a Docker image, what is basically a Docker image, how to create it, what is Docker file and all that stuff. Okay, so let's first understand why Docker. Okay, so forget about this Docker community and all, but the main point is this: Docker engine and Docker hub is equal to Docker platform. Now I'll show you what is Docker hub. Docker hub is, let me just go to Chrome and open one Docker hub. So this is a repository actually, like we have a MVM repository, right, which is a repository for jar files. Similarly, Docker hub is a centralized repository for Docker images. Okay, what is Docker image we will see, but this is a registry, a common registry, a central repository for different Docker images. Okay, so if you need any Docker image for your own purpose, so this is the place you will find that Docker image. We will go inside and we will be exploring this, but this is what the Docker hub is. Docker engine, basically Docker is made up of mainly two components. Let's see those two components, actually the main components. One is the Docker CLI, that is we run different Docker commands, right? Yesterday after the installation we executed few Docker commands, so though that is nothing but a Docker CLI. CLI stands for command line interface. And another component is Docker engine. This is a Docker engine which is comprises of Docker daemon here, right? So Docker daemon it is. See here, Docker engine, Docker daemon, and Docker CLI usually is on the client side. I mean, you will execute the Docker commands. Whatever the Docker commands you execute, those actually get submitted to Docker engine, and this Docker daemon basically keeps all your Docker images and Docker containers. Okay, so we need Docker CLI and we need Docker engine, Docker daemon. Now so Docker daemon, what does it do?
So Docker daemon is also called as Docker engine?
Yeah, Docker engine, it is one of the component inside the Docker engine, Docker daemon. That it does the main tasks of building the images. So when you when you run the command of Docker build, which is an instruction for building a Docker image, so that actually gets sent to this Docker daemon, and that Docker daemon actually builds the Docker image. So it's one of the component inside the Docker engine. Okay. Then it runs and manages containers. We will see what is container, but Docker daemon actually builds the images, it does the stuff. When we say Docker engine, Docker daemon is one of the component and Docker CLI is another component. Docker CLI is our command line interface which we use to run the different commands, and Docker daemon is the one which takes care of building the images, run and manage the containers, right? Then this is what Docker CLI is, Docker commands I mean. So these are those commands which we are going to learn now. Docker build. So this docker build command is used to build the Docker image. Docker images, this command is used to list down different Docker images you have on your system. See, list all images on Docker host. Docker host is what? Docker host is our system where the Docker is installed. Okay, now this laptop of mine where I have installed the Dockers or Docker components, that is called as Docker host. Okay, Docker run. So this Docker run command is used to run the Docker image which will create the container. Yes, someone has raised hand. Yes, Ramesh. Yes, Ramesh.
Yeah, Pranati, basically, I just wanted to understand that, like, basically, what is meant by a Docker first?
Yeah, definitely. I am going to talk about that, what is meant by Docker and everything. But let's first understand the different things related to it, and then we will dig into it. Like what is Docker, why to use it, how to use it, what it is, everything. But let's first understand few things, because these are the things which we are going to use mainly while we will be using Docker. I understand your point, but just give me few minutes. I'll be coming to that point. Docker stop and these commands. Now this is the architecture of Docker. Or let me, okay, if you want me to first talk about what is Docker, let me talk to that first then. Are you aware of VM machine, virtual machine? Are you aware of that concept, Rameshri? Virtual machine?
Yes. So basically, virtual machine also has the same configuration as we use in the original laptop or the desktop, but then we will have to log in with some credentials, and unless or until we have access to it, we will not able to access it, and it will be centrally maintained by some
right. So we have a
organization.
VM machine, right? So where we can, I mean, on a same system of yours, you can install the VM machine. So that machine which you create, so that machine basically uses different resources from your system, like the hard disk of your system, RAM of your system, right? So it creates its own kernel also. So it creates its own resources, right, to execute on your system. So you can say like Docker containers are also like VMs, small VMs. I'm just telling you, it's not exactly like VM, but I'm just telling you just to make it more understandable. You can see Docker container as a VM again. This is a small machine. This will have its own operating system. Okay, let's say this is a Docker container. Okay, so I'll tell you like what does it contain. So this contains its own operating system. Okay, first point. Then it contains its own kernel also. So it doesn't uses anything from our host system. Another very important aspect is for our applications. Now let's say I want to deploy my application, say Java application for example. Now if I deploy my application on my system which has got some different environment, let's say our operating system is different, maybe a pack of the operating system on which I have deployed that application, let's say is different, and now you are testing that application. So I am a developer who is developing that application. I have installed and deployed that application, developed it, unit tested it, and now I have given it to you for your testing. Now you have deployed that application on your system and you are testing it. Now there could be the differences between our environments, maybe a pack on which you are testing this application, OS pack, and the pack on which I have tested that application, developed and unit tested that application could be different, and we could have the issues there. Like you might see the issues in testing which were not there on when I tested it, because due to some environmental differences you got those issues which I didn't get, right? So this kind of stuff happens even in the production also. Like you will test your application, you will deploy that application on the customer's environment, but still there would be few differences in the environment in which the customer is using and the environment on which you are using or you tested, right? So Docker is a platform which will help you to package your application along with its environment, you can say, right? So it's a container. So this container will have everything, what operating system you want, then let's say what version of the Java you want. Let's say for example like the applications prerequisites also would be there inside this. See, app prerequisites. Let's say Node.js application you have. So you will have Node.js, then you will have npm package manager, right? So whatever your application requires to execute, all those things you will package and you will give it to the person who wants to run this. Now let's say you have built an application, Node.js application, and I want to execute it. Okay, so I need to install everything on my system. I need to take the Node.js, I need to install that on my system, I need to take npm package manager, I need to take your system, applications, say compile library, whatever you have generated, and then I will execute it on my system. So I need to do all those setups on my bare metal machines, right? Now if I am done with using your machine, then I need to uninstall it again. But again it will have some kind of footprints on my system, right? Even if I uninstall it, still things would still be there. Few things here and there would still be there on my system, right? Removing that application along with its prerequisite, installing that application along with its prerequisite is quite a task when we say we want to do it on our system. But if you do that setup inside a container, this container is like a box. Okay, this container has got everything inside what it needs to run your application, or Node.js application or Java application or .NET application or whatever kind of application. Now once you want to use this, you will start this box, a container in which it has got everything. Once you are done with the usage, you can simply delete that. You will not have any footprints of this on your own system. That is the main advantage of Dockers actually, right? So you can package your application along with its environment and give it to someone who needs it, either tester. Let's say developer has developed the application, so they will develop it, they will package that application inside the container, and this container then someone else can also run. So everything related to that application will remain in this box only. There will be nothing outside of this. Okay, that is the main thing. When you will deploy it on the customer's end, he just need the Docker setup, okay, and now he wants to run the application. So what he will be doing, he will be running a container on his system which will have everything. So the same box or same container which you tested, no differences in the operating system, the package of the operating system, or any kind of differences in the version of the Java, differences in the version of Node.js, difference in the version of let's say for example Python, whatever. Okay, there won't be any differences. Everything would be boxed, packaged inside it, and you just need to take it and run it. That's it. Are you getting my point? In case of VM, the problem is This same thing can be done on VM also, but VMs are not lightweight in the sense that if you create multiple VMs on your system, so the VM takes a different kernel resources also from your own system, hardware resources, RAM, so they are quite heavy in terms of size, right? Docker containers are very lightweight VMs, you can say. Okay, if it helps you in understanding it as a VM, then you can understand it as a VM, but a lightweight VM, right, which can be programmed also. Programmed in the sense, I can build this image. Image means what? Like, I'll show you the now I'll explain you what is image and what is container. Okay, image is what and container is what. Let me just scroll down and I'll just explain what is image here. Basically, image is what I can say, like, image is a blueprint, like a class. We have a class, right, in object oriented languages. So class is a blueprint which gives you the understanding of, okay, what this particular entity is going to contain. So image is just a blueprint. I'll just define it here. This is an image. It's just a blueprint which tells us, okay, what all contains, right? It's a blueprint. I'll just define it here. Docker image. And container is what? Container is a running VM which is created out of this Docker image. A file system, basically. A Docker image is nothing but the contents of the file system. Say you want a Python there, you want Node.js, you want these files, those files, this operating system, right? So that is a blueprint, what you want, and once you run that image, it creates a small VM which will have everything which you have defined here in the image. So image, and this is a running VM created out of it. This is a container inside which this is a container. So to create a container, you need an image. Image has got everything defined, like which operating system it will have defined, then which version of, let's say, Java it will have it, then all the file system, required file systems, operating system, everything this Docker image will have. Once you will run the Docker image, it will create a short VM, small VM, which will have everything you have mentioned here in this Docker image, right? So Docker image is like a class which is a template which tells you about a particular entity, what this entity has as an attributes, what this entity has as an capabilities, and object is the Docker container, right? So object has all those properties, whatever you have promised in your class. Similarly, whatever the file system, the different versions of softwares you have defined here in this Docker image, those everything would be there in the Docker container. So Docker container is a VM created out of a file system defined in Docker image. Clear now? Understood what it is actually in these terms? Or what are the advantages, maybe you can say, of Dockers? Any questions so far? Rameshri, any questions here? No? Okay. Okay, so like you can see here, the host is my system where I have a Docker. I have a Docker daemon which is going to take care of creating Docker images, Docker containers and all. I have got containers. So let's say I want to run 4 applications, for example. Assume like you don't have any Docker technology. Now if you want to run those 4 applications, then you need to create, let's say, either 4 VMs having those 4 applications running, or you will install everything which you need for those 4 applications on your system, right? Instead of that, what you will do, you will create 4 containers. So this container 1, let's say you are running a Java application, for example. So what operating system you want to run it on, which Java version you want, all that stuff would be running inside this box. Container 2, this is again a small kind of a VM, okay, which will have everything you need to run a Node.js application. So right from the definition of the operating system, the Node.js version, everything you will have here. So there won't be any conflicts. That is very important point. Like if you I have seen this kind of a problem where a developer of a Node.js, he is developing the application and now some other developer joins him. Now when he takes that application from the first developer, then he starts getting issues because the Node.js version that other developer has and the Node.js version the first developer has, there is a difference out there. The difference is in the npm package also, right? Various issues we get if we try to deploy an application from one machine to another machine due to the differences of the versions in the prerequisites. So it would be better if a developer develops the application and inside the container, and if another developer joins him, then simply what that developer will do, he will give the Docker image to him and he will say, okay, run this Docker image and create your own container there and use it from there. So there won't be any differences, right, in terms of the prerequisites and all. So Docker client is nothing but this Docker CLI. Docker CLI is a client. So when we give any command like docker space images, docker space build, those commands, those actually get sent as a request to this Docker daemon, and then Docker daemon serves that request. Then Docker Hub, I already mentioned this, that Docker Hub is a registry which contains the Docker images. Now let's say I have built one image which has got a Node.js application deployed. Now you want that application on your system also. Then what I need to do is I will create a Docker image. So Docker image is a file system, and all the files related to that image would be here inside the Docker image. I will create a Docker image, will push this Docker image the way we push jar file, right? The way we push jar file in our Maven repository, and someone who needs it, he downloads it from there. Similarly, in case of this, I'll create a Docker image. Docker image will have all the required file systems, all required files, operating system related things, everything. I'll create the Docker image. I will push this Docker image to some repository, and the user who wants to run it or use it, he will simply pull the Docker image and he will run the container. So that whatever is there in that Docker image, all the files and everything would be taken and a new machine would be created on his system, right? So Docker pull is a command for that. We will be seeing that Docker pull. This pulls the Docker image from a Docker registry or Docker repository. Docker run uses that image and runs a VM container, right? Docker Hub is the registry, as I said. So you can create repositories. So it's like a GitHub. So on a GitHub we can create different repositories, right, for our code. So on this platform also you can create your own registry. Let me just sign up so that I can go inside and I can, show you few things here. We can create here different kinds of repositories, a private repository, public repository, and all that. So just a minute. I'll say, yeah. Sign up. See if I have. Correct. See, this is the repository. So I have logged in inside this, and I can create repositories of my own. The way we can create repositories, right? Way we can create a repository to contain our code on Git. So similarly, we can create a repository here to contain our Docker images. Okay. So we can create public repository. So if you create a public repository, the Docker images which would be part of it, anyone can download those. But if you create a private repository, then you can restrict like who can use the Docker images and who cannot. And you can see there are various Docker images here. Let's say MongoDB. There are various official Docker images. See, this is a database, Mongo. Now, if you want to set up a database on your system, then you have to make sure that you have all the prerequisites which that database has, right? Say this version of the operating system, that version of operating system, then let's say for example Java it needs. Now we also face this issue in Jenkins, right? Jenkins only supports JDK 11 and JDK 17. Now if you want to set up a Jenkins on your system, then you have to make sure that you have that version of the Java. You need to make sure that that version of the Java is in the path environment variable, or Java home is set there, right? So we have to take care of everything related to setting it up on our system. Even if you set up it on your VM, still you have to make sure that everything is there set up. But Docker image, this particular, let's say Mongo Docker image, has everything, whatever Mongo needs to run. It has got everything inside. You have to simply take the image and create the container. It is as simple as that. Otherwise, it is very difficult to install the software. Difficult in the sense we have to maintain their dependencies. We have to make sure that we have got everything what they need. So Jenkins, if I want to set up, then I have to make sure that I have all those required things. But if I go here and say Jenkins, so Jenkins has their official Docker image. See, if I just simply take this and pull, it will pull the Docker image. So that Docker image will have everything what Jenkins need to run, Java, this, that, blah, blah, blah things. And now if I want to run my Jenkins, I have to simply run the container. I'll show you this, but let's first understand different points. So here you will see different Docker images like Jenkins, then MongoDB, say Redis, another database. See Redis. So Redis also has its own Docker image. Now if I want to show you, these are the Docker tags. We will see what Docker tags is, but let's go and explore a few things. Let's go here. And see here, this is the content of the image. So you can see here they are adding few files, then they have defined some kind of an environment variables, env, this is the Redis version. So these are the contents of that image, files, different file system contents of that image, right? So here, so this is the content of that Docker image. We will see once we will create our own Docker image now. I'll take you inside and I'll show you, okay, these are all file systems which have already been, which are already there, which we get usually when we install the software. When we install Jenkins now, we get all the files. I'll show you that also, which files we get. Once we, let's say, take an example, Jenkins. If I install Jenkins, then I get all these things. Let me go to program data, Jenkins, these things we get, right, when we install Jenkins. Now inside the Jenkins image, all these things would already be there, right? All these file systems would already be there. That is Jenkins image. And once you will run that Jenkins image, it will take those file systems along with the operating system, kernel, whatever it requires, and it will create a small VM, a small container on your system, which will be running Jenkins for you. Right? This is as simple as this. Otherwise, it is difficult to install Jenkins on our system.
Pranay, so with respect to, like, if we take the example of Jenkins, you said that all the files will be there once we download the image, and once we run the image, it will create the container, right? So basically, whenever we install it in our system, we run it, and then, I mean, after downloading Jenkins, we will run it and then we will install, right? So running and installing will also take place once we run the image?
Yes. So it will install, because see, what we do is we first download, then we install, then we get the required files, right, what Jenkins need after the installation, and then we start the war file to run that server, right? So all these things will happen once you run the container, because the Docker image will have all these file systems, okay, and once you run the container, it will start the server also. So installation and running, all the things would take place once you run the Docker container and once you run the Jenkins in Docker container. Got it? Now when we install Jenkins, we first install JDK 17, right? If you remember, we install JDK 17. Now if I go to Jenkins image, let me go to Jenkins image. I'll go to the Jenkins Docker image. Okay, and let's say latest, and let's see. Now here you can see they are already using JDK 8, so they are taking care of it, of getting the required Java from. We will see what this from is. So they are taking Java and then they are adding their own stuff. The Jenkins people, they are adding the Jenkins related stuff into that. So they are taking care of JDK they need, right? And then they are setting the user, group, all that stuff, HTTP port. So if you remember, we had open one file and there we had set our port. Even for Nexus also, we had open one properties file and there we had set the port. Here we had set the port. Another very important thing, now when we install Jenkins and Nexus, on our system, then we have to make sure that both of them should listen to different ports, right? But here my Jenkins can stay running on 8080 port if it is running inside the container. My Nexus can also listen to 8080 port because it is going to run in its own container. Jenkins is going to run in its own container, so there is no port conflict here. But when you install these things on your system, then you have to make sure that there won't be any port conflicts. You have to make sure that you have the required Java and all those stuff, right?
Okay, so I have a query here. So it means that just for understanding purpose, so each container will act as a VM, is it?
Yeah, it is. Yes,
I mean,
it is.
just for understanding purpose.
Yeah, just for the basic understanding purpose, you can say that each container is a VM, a different VM.
Oh, okay.
Okay, so there won't be anyone, interfering in there, anyone's system. It is very easy to create that VM, even delete that VM also. In case of virtual machines, it's not that easy. You cannot even, let's say I want to create a virtual machine for my application, which will only be running my Jenkins application. So I cannot code like what I need there on that system. The way I can do it, we will see the Docker files. So in the Docker files, I can say, okay, for running my this particular application, I need this, I need this, I need this, I need this. So I can code it, what I need. Then from that I will create a Docker image, which will have everything which I have defined there, all the file systems, all the softwares and all that, which will create the image. And then I will run the container, which will create a machine from that file system, right? As simple as this. It's very, now we are so much used to these things. No, we don't in our organization, our Jenkins runs inside the container, our Nexus runs inside the container, because we don't set up the things on the bare metal systems now, because they have their own disadvantages. As I told you, you have to make sure of having everything what they need. Here I don't care. Jenkins, they have already taken care of everything. As soon as I pull the image and run the container, that will have everything which Jenkins need, and it will even start the server also, right? It's very easy. So this is the Docker Hub which we just talked about. Yeah, we will see this Docker installation, or rather we have already done this Docker installation. Docker Hub, this is what we were doing. Like currently we are exploring different images. I'll show you few other images also. There are a lot of images. Even Nexus also has their image. So not like Nexus. So we can run our Nexus repository, which we are currently running on our system. We can run here inside the container. Sonatype Nexus it is called as. See here, Sonatype Nexus 3. This is their Docker image. Yeah, they also provide, like we will see what this -p is, what this -d is. That's not a problem. We are going to see all these things. But the point is, every every system, software system, now they run inside the containers. No one installs those on a bare metal system, or rather no one wants to, right? Yeah, so we will see this flow once we will start building our own images, right? So Docker run commands we are going to see. Build images, we can build our own image, or we can even get any image which is already built here, and we can run the container. You can create your own image according to your application need, and you can push that image on some platform, and the person who wants it, he can pull the image, run the container, use your application. Once he is done, he will delete the container. Simple. There won't be any footprints on his own system. I don't need anything on my system. That is the main advantage of this. It's very easy to take, run, and once done, delete. Now, in order to delete my Jenkins on from my system, I need to delete that. I didn't want to install JDK 8, but I had to because my Jenkins wanted it. I didn't want that Java to be in my path environment variable or my Java home to be pointing to that. Now this is a serious issue. Seriously, I'm telling you that now my Java is pointing to 1.8 because my Jenkins wants it, or my Java home is pointing to JDK 17 because my Jenkins wants it. But let's say some other application which I am using needs a different version of Java. It has got its own requirements, and I had set up that software on my system, and I had done all those arrangements, but now I had to change those arrangements just for one Jenkins, and which is now, let's say, creating an issue to my other application. This is a serious issue, right? But if I run Jenkins inside the container, I don't need to do any kind of adjustments on my system. I will run the container. Once I am done, I will delete the container. Simple as that. This is a huge advantage actually of container environment. Yeah, we will see this. That's not a problem. Okay, now let's say I want to run Jenkins. Okay, I want to run Jenkins. Now let's go to Jenkins. I'll show you how easy it is to run Jenkins inside the container. I'll just scroll down. We will see this is the tag. Tag is what? Version. So they have got different versions. Okay, so latest is the tag which defines the latest release from Jenkins side. Okay, a latest release. A latest tag always points to the latest release of a particular Docker image. Okay, this is the way you can version the software, right? Latest always points to the latest, and then you might have different versions, 1.0, 1.1, 2.0, 2.1, like that, right? So this is the way of versioning. Now let me just open, and now our very first command which we will execute now is docker pull. So what that docker pull will do, it will take the image and it will download it on my system. Okay, so the first in the workflow, the first thing is what? If you want to run any software, let's say inside the container, you need to get the image. You need to get the image in which all the prerequisites and all that stuff has been defined. So that is image. You need to get it on your system first, and then you can run the container. Okay, I'll show you now. Let me just take the name. Yeah, here it is. See here, docker pull Jenkins. Simple. I will copy this and put it here. See, it is pulling the image now. It will take some time because I have
your screen is struck. We are just able to see the.
Yeah, maybe because of the network issue. Just a minute. Let me share the screen again. Because I am on the mobile network actually.
Okay.
That's the reason. Let me share the screen.
Yeah, even sometimes the voice is varying too. So.
See, I am not able to pull the image because of the network issue again. Are you able to see my screen now? So now this Docker pull will pull the image.
Yes.
This Docker pull and the name of the image, and by default it takes the tag as latest. By default the tag always it will take is latest, but if you want some other version of the Jenkins, say a specific tag, then you can mention that tag also. Let me just control C this and I'll show you how can we mention the tag. See, let's say if I want to use this 2.60.3, this version of the Jenkins, say, then what I'll do is docker pull Jenkins colon and 2.60.3. This is how I can pull a specific version of Jenkins image. Right? So this is what the tag is. It is for versioning. 2.60.3. Then they have got different versions. The way we have for jar files, we have got different versions. Likewise. Right?